to their ancestors from those same civilizations, and pay my respect to the elders and any Aboriginal or Island Strait people that are here today. So I'm going to try to keep this as easy as possible, because I think learning any new technology, simplicity is always the best way to start. So I'm going to keep it pretty high level, but we're going to go over all the different concepts, at least that you would need to get started with any kind of automation through Terraform / OpenTofu, and I'll explain that here in a bit as well. So I'm going to cover the what and the why of Terraform, so you have a good idea of what Terraform is, and then how OpenTofu applies to that, and why you would even consider using that, and how the ecosystems are pretty much the same. I'll cover why you should even use OpenTofu, if you should even use OpenTofu, and that's going to be a decision for you to make. And then I'm going to go over the OpenTofu and Terraform basics, so you'll get to see us actually. I'll have some slides up here to kind of show you what happens, and then I'll go actually start keying some stuff in, and you'll actually get to see it in practice. And then we'll cover some continued learning resources as well. So the what's and why of Terraform. So why you would even need Terraform is you need to automate your infrastructure. This is one of the original infrastructure as code tools that has ever existed. And so what the goal of Terraform is, or even OpenTofu, is to provide you with a framework that is very easy to automate any of your infrastructure. Now, what kind of infrastructure can that be? That can be virtual machines, that can be networks, VLANs. It could be the security infrastructure. It could be the applications themselves, containers. You can even, if you have the right provider, which I'll talk about providers here in a second, you can even use it in place of some Ansible tools if you want, if you need to configure that infrastructure. But I will say that a lot of people do use Ansible and Terraform together. They typically use Terraform to automate the actual infrastructure and bring up the environments themselves. And then you use Ansible to automate the actual configuration inside of the environments as well. And so that brings us to providers. Basically, what providers are a logical abstraction of the APIs that exist to interact with whatever the infrastructure is. And so you could go build one yourself. You'd have to build it using the Golang language. But basically, you would write the logic that would interact with the APIs to provision your AWS EC2 instances, or provision your Route 53 instances for your namespacing and everything for your URLs, or something for AWS, or whatever the equivalent is for GCP or Azure, or even doing things like that on VMware. So providers are the interface for how you actually interact with the infrastructure that you need to interact with. And that could be practically anything, because they have providers now at this point that cover pretty much all the clouds, even the smaller clouds, and they have it to where the providers interact with all the on-site, on-premise infrastructure as well. So VMware, Cisco actually has quite a few with UCS and Intersight and things like that as well too. So the other thing is Terraform is state management. So being able to deploy your applications is great, but you also need to manage the state of those applications. You don't want to actually use the automation to deploy when you don't need to deploy, or to not know if it's been taken down by someone else. So state management, what is going on with your infrastructure, is actually stored in a file, which we'll see a little bit later when we do more of the on-hand stuff, on the computer itself. And so, or where the Terraform is actually living. And you can maintain that state and store that in a repository and update it as you need it as well. But it's very important, because that's how we know what we're doing and what Terraform needs to do to update your infrastructure as you need. The other thing is Terraform uses a declarative language. Now it uses something called HCL, and it's basically in a JSON-ish type format. And what that means is you define what your environment wants to look like, and that's all you have to do. It's the end result. So you put in, say, hey, I want 5 VLANs, and I want them to exist on this network, and I want 10 VMs spun up on top of this network to exist as well. And then you can, depending on the provider, you would give it the resources and how that would look. And then Terraform just goes and does it. What's great about that, and this is why I talked about state before, is what can happen is as it's maintaining that state, when you update it, because it's declarative instead of imperative, which I'll talk a little bit about that in a second, it basically can go and say, hey, just update this. And then it knows, say, hey, before they asked for 5 or 10 VMs, now they're only asking for 5. I'm going to tear those down. And it knows that because of the state management that it works together with its declarative language. So the brief note on declarative is I always like to say what kind of it means. It's basically, the way I like to think of it from a conceptual point is declarative versus imperative. Declarative is the Steve Jobs to your Apple. You want an MP3 player, a camera, and a phone in one device, and it just does it. He didn't have to list out all the engineering tasks for that to happen. That happened by his team. Essentially, Terraform acts the same way. You tell it what you want. It already, because of the providers, it already has worked out how it's going to execute the infrastructure that needs to be pushed up into your cloud, your data center, your network, whatever. So, and that brings us to the benefits, is because we have this, we now have a simple infrastructure tool that allows us to be able to interact with a whole bunch of different infrastructure items without having to know all the different languages for having to do all that, or write some code sample that does a Python script over here, and we use Ansible over here, and we use PowerShell over here because it still uses Windows or something like that. If there's a provider for it and it can interact with that system, that's all you need. You define it in your HCL file for Terraform, or your TF file for your when you're going to deploy, and it will do it. And then the syntax might change very slightly depending on the provider. If you have to give it more information depending on, I need this VLAN with this subnet, etc. Now you may not have to give that same information to a container, so some of that will be slightly different, but the base wrapper of the language is pretty much the same all across the board, no matter what you're doing. There's also a really great community behind Terraform, and this is another value of it, having that community, having people that use it all the time. This is kind of what I even tell people about Kubernetes as well. One of the things that's very valuable about that ecosystem of using Kubernetes is there is no shortage of people that can help you. Whether it's HashiCorp themselves, if you're paying for support from them, or you're using their cloud service, or even if you just go to the forums or anything like that, there are tons of people that can help you with anything you're having trouble with, or just even the learning resources as well. So it's very excellent for that. And then kind of the last point for the value, the why I would even use Terraform, is the versioning. So this becomes very powerful because now I can version all of my infrastructure. If I have a different, like, hey, network 0.1, I'm now moving and changing it. It's now 0.2 or 0.11 or something like that. I can then roll back to different versions if I know this infrastructure was working before, but we did this new deployment. Now we're having this bug or this issue. It's not working. This application isn't working on it anymore. I can either roll back to a different version, or I can just maintain and see where problems existed or didn't exist between different versions. And then I can keep a diff of each of those different versions in source control using Git and all the code stuff that we teach about here at DevNet. So now, why OpenTofu? I'm going to go through this part pretty quick. There's a little bit of a brief kind of side. There's different sides of Terraform. Terraform was originally a letter in 2011, basically stating, hey, this is what we should have for our infrastructure. It should be easy. It should have these things. And then about 3 years later, the original founders decided to execute on that, and they created Terraform in 2014. That's led to, hey, now that we have Terraform, we are going to build an ecosystem around it. We're going to get community people. We're going to get everyone involved, and then we're going to keep ramping up this project. And so they start doing that. They get community providers. People build stuff so it started off just being with AWS and DigitalOcean, but then it evolved into the other cloud services. It evolved to infrastructure on site. It evolved to networks. It evolved to even applications. If all you just wanted to do is deploy an application, there is a Terraform provider that'll do that in some cloud service off somewhere. So it even goes a little bit beyond, infrastructure. But then they started developing a large enterprise around that and doing that kind of thing. And this last point, this is kind of like a joke. I'm not really giving Terraform or HashiCorp a hard time for doing what they did, but they did switch their license just this year from an MPL, so a copyleft license, to more of it's what they call a business use license. So the source code is still out there, it exists, but it's not open source anymore. And so basically what ended up happening is the community got, not everyone, but a big portion of people got upset. They were like, there's some trust broken. Now, for me, from my standpoint, I'll be honest with you, I can actually see it both ways. They are doing what they think is right for the business. Most people aren't going to end up in a competitive situation between HashiCorp and themselves when they're using Terraform. So should they use it or should they not? That's kind of a, thing there. But that said, OpenTofu was created by the community. It's basically a drop-in replacement for Terraform. So, and that's kind of why we're here to talk about that and use that. Is, to be honest with you, the reason I'm even talking to you about it now is I've just talked to a lot of people when I've gone off and used it myself after using Terraform for a long time, where they're just like, well, I don't know. It's a new thing. I'm not sure if I should use it, but my company's not really, they don't know if they're okay with the licensing now with Terraform and how it's being used. And we still have to work that out with legal. And I'm like, we should just try it. Well, how do I get started with it? It's real easy. They've actually made it real easy just recently. All the same tools that you can use to install it on your computer when you're using it to get started are, like, so if you have a Mac, it's just brew install. They have images on their GitHub repository you can load up for Windows or whatever if you have that. You can do an apt install OpenTofu or Tofu, or I forget what the exact command for Linux is, but they've made it real easy for you to install. So it's just as easy to install. It's basically a drop-in replacement. And now you can try it out and use it for yourself. Now you might have to decide how you're going to do that. And that's just kind of where, should you use OpenTofu? And I'm gonna cop out on you, really, I'm gonna say it depends. All those things I was telling you about, you might have to talk to your legal department to figure out if it's okay for you to use Terraform. If it is, maybe just stick there. Maybe you're so ingrained in the Terraform ecosystem to begin with HashiCorp and you use their cloud and all that kind of stuff, it doesn't matter. So you're gonna go that way anyway. But knowing that you can use OpenTofu just as easily is important. So that's why I've included it into the intro to Terraform here. So let's get to the Terraform basics. I'm going to kind of briefly talk about it, then I'm going to start using some of the commands so you can kind of see just how it works just the same. So the first thing you start with, so let's just say you already have your main.tf file, which is going to have your basically what you want deployed, the resources, the provider you want to use, all that kind of stuff. The next thing you're going to do is you're going to do tofu init. That's going to initialize. It's going to look at your Terraform file, and it's going to say, oh, you have these providers. I need to go download those. I need to initialize those. I need to get them ready for when we actually use Terraform. And so it's real easy. If you wanted to, if you also had the Terraform binary, you can just put Terraform right there, and it will work exactly the same. That's what I'm saying. Drop-in replacement. No problem. Easy. The next thing we do is we do the tofu plan. This is basically going to create a little binary that's going to basically tell Terraform how it wants to write out basically all the different steps it needs to provision your infrastructure. And again, this kind of goes back to the whole state thing too. It's also going to, if there's a state file, it's going to look at that and say, oh, let's just say you wanted one more of something, but you already had one of another. It knows it only needs to give you one more instead of just saying destroy and then add two more. So it uses those kind of injunction, but the plan helps tell Terraform how it figures out what are all the steps that need to be done. And this is kind of where I was saying this is the difference between the declarative and imperative part, right? Is declarative, you just tell it what it wants, it figures out that part. If it was imperative, then you would be sitting there, okay, destroy this resource, then add this resource, then put this resource, and then do it in this order. And then you would define all those different steps. You don't need to do any of that. You just need to say, hey, I need this end state. Done. And so Terraform plan helps you do that by, after it's done the initialization, it then re-looks at that Terraform file that we have and then says, good, we're going to make a plan for that. And then it creates the plan file. The next part is we apply. Once we apply, it does exactly what you say it's going to do. It's going to go take that plan file. It says, here are all the steps of the things I need to do. It's going to go execute those steps as you need them. It really is this simple. This is why Terraform has been as popular as it is. We are now at the state we are deploying our resources that we need for whatever the other applications that we're going to be deploying on it are. We're building up all this infrastructure that we need to support our networks, our businesses, everything we need, as easy as a tofu apply or Terraform apply. Now, maybe our resources are more ephemeral and we need to take them down sometimes. Maybe we're just spinning them up temporarily. These are actually things that we deal with our sandbox team and DevNet when we're providing you resources, like for technologies that you need to use to, like, hey, I want to learn about NXOS today. We spin up environments. Well, we have to tear them down as well. So we have to destroy those. Depending on your use case, you might use that quite a bit. And so we use that to destroy it. And then there's one other command I like to kind of tell people about, because I feel like it's important when you're getting started, because most people overlook this one. They'll do the other 4 commands I've shown you. This is just one of those, cheat tips from Jock kind of thing. Is tofu refresh is actually really important, because what it does is if you, sir, are working with you over here or you over here, and y'all are updating parts of the infrastructure and y'all doing the same thing, but even if you're in dev, maybe you're changing the infrastructure on your side, but he comes in because he works a different hourly shift than y'all, and he says, hey, I want to update it now, right? And so what happens is your state is now out of sync. And so then when he goes to apply Terraform on his computer, he's not going to know what the state is unless he does a refresh. If he does a refresh, it's going to actually reach out and make sure those resources are where they're supposed to be and they are what they're supposed to be. And if it's not, then it will update the file so that way it'll at least know, hey, now this is my starting point. And so that way it won't forget to delete something that it needs to delete, or put something there that it thinks isn't there, that type of thing. So you won't duplicate services. It's important. So really quickly, I'm going to get out of this and let's see if we can see my code editor. Here, let me clear that off. And then let me increase the size so we can see that better. Actually, I'll close this for right now. Can everyone see that? All right, ish? Okay. So here, I'll kind of go over this. This is the main.tf file. This is kind of what you would start with. Pretty simple, basic kind of file. Up here, even though I'm still using Tofu, I'm still going to define Terraform. I'm going to require my providers. In this case, I'm just doing a simple example with Docker. I'm going to provision some containers. I'm going to tell it to open some ports. I'm going to do something simple. Again, the reason why I would do this instead of using a Docker CLI is that same benefits that we were talking about earlier. I can use this same tool for deploying NXOS or VLANs on iOS XE or whatever it is. I can use this tool for multiple different things. That's why I'm not just saying Docker run whatever, that type of thing. This makes this easier. I can version this. That's also a little bit easier for that. Anyway, So I put my required provider, which is Docker. I put the source where it can find that provider. So this is where it reaches out to a provider repository where the binaries for that are stored. The Go program that was written as the provider to interact with Terraform, that's that provider layer. And then it's gonna, here's the version I'm using. So I've got all that defined. And so now I say, okay, hey, here's the provider. This particular provider needs to know where the host of the Docker connection is. In this case, since it's just on my local computer, I could do it here. If it was remote, I could give it the remote address right here as well. That said is then I say, hey, I define my resource, my Docker image, also Nginx, and then I give it a name. This is just so it'll know what the name of the resource is. I've defined this because this is my Nginx container I'll be deploying. And then let me scroll up here. And then here's the actual definition of the container itself. And so I'll give that the Docker container name. I also say it's Nginx, image name, the name of this context right here. Here's the ports. So this is where when you're defining this resource, depending on what this is, if this were a network, I might have subnet under there instead of internal, external ports or whatever. I might have something like that too, but in this case, this is specific to the provider of Docker. All providers do have documentation typically on what parameters you need to give to make them work. And if you use the learning labs for any of the Cisco the Cisco providers that are for Cisco products, it should give you instructions on how to use that for your networking and other infrastructure operations as well. So just an easy kind of deployment there. So what I'm going to do, just so you can also see what's going on here, I'm going to delete a few resources. So that way you can see what it does when it creates. Because I can start with just a base main Terraform file. All right, let's get a terminal here. And so then I'll say tofu init. And so it's initializing the providers, which is reaching out to the provider repository. It's downloading all that. So it's working on that right now. And then you'll see that populate up here in a second. Boom, there it goes. It has all the information it needs now for that. So then again, I say Terraform plan, but I'm going to give it a flag. So I'm going to say out and TF plan. And this is going to create the plan file that Terraform will then use to do all of the resource like resource activities it needs to spin up the environment. Oh, wait. Hang on one second. Oh, I actually messed up. I got to do this part, tofu. There we go. All right, then it created my plan file. And this is the binary for that. So if I opened it, it would just kind of look like garbage, but it's just in binary format. So now that I've created my plan, I then say tofu apply. And are you sure you want to do these actions? Yes, I am sure. So I'll say yes. And then it created it. And then if I wanted to come over here and create a new, or just say Docker, we can see if it's running. And then you can see, hey, we just spun this up 16 seconds ago. So it talked to the Docker daemon. It was able to do that. And it's all doing this through Terraform. And that provider is the basically middle interface in between Terraform and Docker. But this could be Kubernetes, again, VMware, AWS, GCP, whatever. And then now this is where I would go tofu destroy. And then yes. And then let's see up here. Oh, you know, I may have, let's see. I think that error is fine. Here, let's see. Docker ps grep nginx. Yep, and so that it destroyed that because it didn't come up here. So we're good there. Let me actually move back over here. So at this point, again, like if I was also working with someone else and I needed to update my state, I could do that here. I could do that refresh part. And so this is where the state is stored, but it also keeps backups of that state. So the backup was kind of when I did the refresh. That's what it moved whatever was in the original state back to here. But the Terraform state should be the current active state of my environment, whatever that environment is. In this case, Docker image manage, whether it's in there or not, that type of thing. So that's all stored right there. And then that's pretty much it. It sounds like it's really that easy because it is that easy. A lot of things like that are very complex. Sometimes you go through tutorials that are a little bit more complex than they need to be on Terraform. But if you're just looking to get started and you're looking to try this with your infrastructure, you can do this. If you have something like an AWS account, you just need to be able to give it the right tokens and creds to be able to connect to that account and then provision resources there. Same thing with Kubernetes. You typically have to have some sort of login information if you're going to be using it for that, or your network. You can use that for any of that stuff right there. And then last but not least, for continued educational resources on Terraform, especially for using this with Cisco products. Let me get out of the way here. Developer.cisco.com/automation Terraform. They have pretty much all the things you can imagine there. They have videos, they have learning labs, they have the different technologies they represent. You can find everything you need to get started with automation with Terraform with any of the Cisco products. And the tutorials are really easy. They walk you through step by step, even just like I did now. Easy, get started. And then you can use the DevNet sandbox or the Learning Lab system itself to be able to use that. Don't forget about your other continuing education as you're here. See the other things in DevNet, do the capture the flag, that type of thing. And thank you for your time. I hope you have a great rest of your Cisco Live. Oh, what's that? A raffle? Oh, okay. Just pull. All right, we're doing the raffle. You think I randomized this enough? Should have wrote a Terraform provider for it. Is there like a last 4 or 3 digits? Just the whole thing? The last 4? Oh, okay, last 4. Okay. 3731. Hey, there we go. Okay, cool. Let's see. Yep. And I got your price. All right, y'all have a great rest of your Cisco Live, and I'll see you out there soon. Yeah, for sure.